Okay, now
Hello everyone, good afternoon and welcome to the ALCTS virtual pre-conference. We can do it, you can too. Metadata automation for everyone. This is a two-part virtual pre-conference being held this week with the next session also tomorrow at this time. I'm Anna Nietrauer, your host for today's presentation, Session 1, Automating Descriptive Metadata Creation, Tools and Workflows, which includes two presentations. Our first presenters today are Annie Gliram and Dominique Bortmus. Margaret Annie Gliram is the head of complex cataloging at Florida State University Libraries in Tallahassee, Florida. She's currently Vice Chair President-elect of OLOC, and she was formerly member of OLOC's Cataloging Policy Committee and the committee's Revising Streaming Media Best Practices for RDA Task Force. Ms. Gliram is also a member of the JSC RDA Onyx Working Group, co-chair of the ALCTS Technical Services Workflows Efficiency Interest Group, and former co-chair of the Bibliographic Control and Discovery Subcommittee of the Cataloging Authorities and Metadata Committee of the Council of State University Libraries of Florida. She received a Master of Library and Information Science from the University of South Florida and a Bachelor of Music, Music Theory and Composition from Stetson University. Dominique Bortmus is the metadata librarian at the University of South Florida in Tampa, Florida. While earning her MLIS through Kent State University, she was the complex cataloging specialist at Florida State University. Before relocating to Florida, Dominique held her first library position at Kent State University as an audiovisual cataloger. She earned her BA in English and Women's Gender and Sexuality Studies from The Ohio State University. Our second presenter is Joseph Nicholson. Joseph Nicholson is the metadata librarian in the Special Collections Department at the J. Murray Atkins Library at the University of Carolina at Charlotte, where he's responsible for original cataloging throughout the library, creating and transforming metadata for digital projects, and coordinating authority control efforts. He has a BA and an MLS from the University of North Carolina at Chapel Hill, and an MA in English Literature from the College of William and Mary. A few things to keep in mind for today's presentation. Today's webinar does not have interactive chat capabilities. If you wish to comment on today's presentation using Twitter, feel free to use the hashtag that you see on the screen. We'll be monitoring the questions or comments on the Twitter feed, but the moderators prefer that if you have questions for the presenters, please type them into the question box on your screen, and the questions will be collected by myself and the speakers will answer them as the time permits at the end of their presentations. Questions which remain unanswered while we're on the air will be answered offline, and answers will be sent to all attendees today. The webinar is being recorded, and you'll receive an email with links to the recording, the presentation slides, and an evaluation within 2 days. Please take time to fill out the evaluation form since it will be used by the committee to plan future events. And now we're going to hear from Dominique and Annie on migrating ETDs from Dublin Core to MODS, automated processes for metadata enhancement.
Hello. Welcome to Migrating ETDs from Dublin Core to MODS, Automated Processes for Metadata Enrichment. In case you're wondering about the color scheme for these slides, Florida State University's colors are garnet and gold, and the University of South Florida's colors are green and gold. I work at Florida State University, FSU, but my MLIS is from the University of South Florida, USF. Dom used to work at FSU, but now she's at USF. The universities just happen to have the same letters. My name is Annie Gliram, and I'm head of complex cataloging at Florida State University Libraries. My background is in cataloging, but I've been working with metadata for electronic theses and dissertations, or ETDs, for the past 4 years. I'm co-presenting today with my colleague Dominique Bortmus, who was cataloging specialist at FSU before becoming metadata librarian at USF. She's responsible for generating ETD metadata for the institutional repository and catalog. Many of the technologies mentioned in this presentation are on our GitHub sites. I'm A. Gliram, Dom is D. Bortmus 12. I'm in the process of refreshing my ETD metadata repository, which was first created a couple years ago. As of today, it contains examples of technologies mentioned in today's session. We'd like you to take a little survey about ETD description. Okay, great. I see some of the answers coming in. It looks like at least most of you work with ETD data at least a little bit. Okay, well this is great. Well, you know, when you hold a webinar and have ETD in the title, it makes sense that the audience knows a little bit about ETDs. Okay, let's see. So, my experience with ETDs began as a cataloger, creating records based on the institutional repository metadata and transcription of information on the PDF. We entered the data into a MARC template developed by FSU Libraries formats cataloging librarian Ye Li. He and I later collaborated to bring that template up to RDA, the new content standard, resource description, and access. This presentation will cover the method Dominique and I used to enhance relatively sparse bpress metadata for the more robust MOD schema. Then Dominique will share how she adapted and expanded some of these technologies at USF. Our session is about 40 minutes, and we hope to have 5 minutes at the end for questions. We have a lot to cover, so we may need to go through some of the slides rather quickly, but the slides will be available after the session. Don't worry if you get overwhelmed by all the acronym soup. By the end of the presentation is a list of acronyms as well as resources for further study. ETD Migration. As members of FSU Libraries' Digital Migration Project team, led by FSU Libraries web developer Brian Brown, with the consultation of metadata librarian Matthew Miguez, Digital Scholarship Coordinator Micah Vandegrift, and Scholarly Communications Librarian Devin Soper, Dominique and I worked together on migrating metadata for over 8,500 titles from the bpress platform, which uses Qualified Dublin Core, to Mods for Islandora, an open source software framework for our institutional repository. You'll have to forgive my voice. We had some storms come through and it's affected my sinuses. So previous to 2012, FSU graduate students submitted their theses and dissertations to the graduate school. Digital library staff manually entered the metadata into Digitool, an ex libris digital assets management tool. In 2012, our students began submitting the materials via ProQuest administration tool. ProQuest then delivered batches of PDFs and their corresponding metadata. During the digital migration project in 2015, bpress metadata was transformed into mods for Islandora. And now that the migration is complete, ProQuest metadata is transformed to mods. Thick versus thin. Thin metadata to thick metadata. We could have just crosswalked bpress data into corresponding mods element, but that wouldn't have taken advantage of Islandora's faceted search results and its potential for name and subject authority control. But even when the descriptive elements were common to both schemas, there still were differences. In bpress, some elements contain a simple text string, where in mods, the data is parsed into sub-elements, such as the title element and the degree element. In the case of keyword, bpress parses each keyword into a separate sub-element, where mods has a comma-separated list. bpress provides a publication date, where mods provides a full publication statement. For the author name, bpress separates the first and middle names, where in mods, those two name parts are combined into given. Mods also includes a date sub-element for authorized name headings, as well as an element for role. The bpress department name is a text string that validates against an internal controlled vocabulary. Mods descriptions, however, can use a variety of international authorities, such as VOF, the Virtual International Authority File, in addition to the Library of Congress Name Authority File. Both bpress and mods have an abstract element. However, the bpress user interface displays HTML tags and references, where Islandora does not. Special characters need to be UTF-8. Anyone who has worked with these theses and dissertations in the mathematics or sciences know exactly what I mean about special characters. BPress schema also allows for HTML in the advisor field. And speaking of user displays, one of the major advantages of moving to Islandora is its ability to limit search results with facets. BPress just has a simple keyword search, so it didn't matter that one student entered their advisor's name as Thomas Keller, another student entered it as Thomas C.S. Keller, and yet another one entered it as Thomas C.S. Keller III. And I'm not making these up, these are real examples. But in Islandora, search results are filtered into facets. So with the case of Thomas Keller, there would be facets for all three forms of his name. Since the priority was to get the new institutional repository up as soon as possible, we decided to only control author names during the migration project. Authority control of the committee member names will be performed as a post-migration cleanup. Our goal was to have the ETD description for the institutional repository parallel the ETD description for catalog records. We wanted to follow RDA and the Network Digital Library's metadata standard for electronic theses and dissertations. Being a cataloger, where transcribed data is entered for titles, we considered the PDF's title page and verso the primary source of information, regardless of what was in the BPress metadata, which, as we discovered while cataloging ETDs from the institutional repository data, is not always consistent with the PDF. Author names should be from a NACO, VOF, or local authority, and subjects should be Library of Congress subject headings. Also included are notes that have become standard in our ETD catalog records. We'd like you to take another quick survey, this time with ETD technologies. Okay, it looks like we have a lot of XSLT people in the group. My goodness, almost 70%. XProc is a little bit more obscure. But I also see that there are some people here that don't have any experience with this at all. Okay, so let's give it just a really brief introduction here. XSLT 1.0 was developed for transforming XML documents from one schema to another. It did this by traversing the XML node tree with apply template to push the context to the next level and access particular nodes and data. This works just fine for simple crosswalking from one metadata scheme to another. However, with the release of XPath 2.0, that expanded the capabilities of XSLT 2.0 to include regular expression pattern matching, if-then-else conditional statements, and iterative expressions like flower, that's for, let, when, or to return, to pull the data, further developing XSLT 2.0 into what I consider to be a very flexible functional programming language. In 2012, when we switched to ProQuest admin tool, FSU Libraries formed a ETD working group. As a liaison for cataloging, I volunteered to find an XSLT for transforming ProQuest metadata to MARC 21. The working group had already discovered Sean Averkamp and Joanna Lee's article, Repurposing ProQuest Metadata for Batch Ingesting ETDs into an Institutional Repository, to use as a model for our new process. There's a citation for that at the end of the slides. However, the programs included in that article weren't exactly what we needed, so I had to teach myself just enough XSLT to adapt their programs. I credit this article as my first step in my journey with XML technologies. I had so much fun learning XSLT. Yeah, I know I'm a nerd. that this became my nights and weekend research project for the next few years. And eventually, that led to the development of the processes that we're sharing with you today. Now Dominique will walk you through the process we use to harvest PDF data. She did the research on using XProc and was responsible for this step of the bpress to mods process.
Before we could begin the migration process, we first needed to generate the PDF data. Through the use of JavaScript, Annie created a simple script to strip the bpress title page, extract pages 1 through 2, which contained the metadata we needed, and save the PDF as XML. After the PDF metadata was generated and converted to XML, we were then ready to run our XSLT scripts. The scripts were pipelined through XProc and reformatted the metadata into mods. After running the scripts, corrections were made where needed, then the final product was produced. With the exception of some manual review, this entire process was automated, which promoted quality control and time efficiency. In order to gather the metadata we needed from each PDF, Annie's JavaScript completed 3 vital steps that significantly sped up the metadata gathering process. I began with the source file that contained the ETD PDFs, then ran the first script. The output of the first script served as the source file for the second script, and so on. Through these JavaScripts, we were finally produced with the PDF data in an XML file. The first JavaScript removed the bpress cover pages. The script counted the pages and was set to remove page 0, which was the cover page. We did not need the cover page since the bulk of the metadata was contained on pages 1 and 2. After removing the cover pages, the second piece of JavaScript extracted pages 1 and 2. The output consisted of the 2 title pages from each PDF that were extracted into a new folder. The third piece of JavaScript took the extracted pages and converted them to XML. We needed the metadata to be stored as XML so we could manipulate and process it through our XSLT scripts. But before you get too excited about these automated JavaScripts, we wanted to point out some of the obstacles we faced. Frequently, we encountered conversion issues. The XML result would be scrambled and unreadable. After running the JavaScript, I would review the XML result for errors such as this one. Since some PDFs had conversion issues, I had to open the original PDF and manually enter corrections for the scrambled parts. These conversion issues occurred in every single batch of ETDs, but usually there were only a handful of them. Other conversion issues occurred when we converted the PDF data to XML. Sometimes there were images included on pages 1 and 2. When converted to XML, the images converted to a scrambled mess of letters. I had to identify these problems, then manually delete the scrambled text from the PDF's XML. And here is the result after PDF to XML to PDF data. As you can see, the result is still scrambled and needs to be corrected manually. In order to make the manual corrections workflow simpler, we created a template for the PDF data. In the event of a bad conversion, I would pull up the original PDF and manually type the metadata into the template. Once all the PDF metadata was properly entered, we were ready to run our XSLT scripts on the XML. The migration project consisted of 10 XSLT steps. We began the source file of all of the PDF data, then ran the first XSLT script. The output of step 1 was ran against the second script, and so on. Doing this for each script became time-consuming, particularly since we needed to set up the configuration and give each output a particular name. In order to speed up the process, I researched some automating alternatives. I found that I could pipeline the steps and their output together through XProc. XProc is a language designed for describing operations to be performed on XML documents. It acts as a pipeline in which each step produces an output that then serves as an input for the next following XSLT script. Through constructing an XProc script, we were able to run the entire process in a matter of seconds. Since the script was configured to provide the output file for each step, we could even go back and review each step if need be. And here we have an example of the PDF to XML result. All metadata is encoded in separate lines, which allows us to run our scripts that targeted particular lines and their content. For the sake of time, we will not go through each script, but we will share a few examples. In this example, we have the result of step 1, in which all the metadata has been combined. While all the metadata we needed for the repository is present, there are also a few lines here that needed to be adapted or even deleted. Step 2 addresses some of these concerns, such as deleting some unnecessary lines like by, approved, the page numbers, and it would even delete the literal lines. The result of step 2 removes the unwanted lines to produce a cleaner XML file, as you can see here. And after all 10 scripts are pipelined through XProc, the final result is produced as mods. And now I will turn it over to Annie, who will now discuss modular XSLT.
Thank you, Dom. Modular XSLT. Using a text editor in command line is fine for editing XSLT and running simple transformations, but for running more complex processes, Dom and I use Oxygen XML software. Oxygen is a comprehensive XML technologies tool. I have only scratched the surface of its capabilities. And one of its most useful features is its project view, where you can organize and run transformations on a collection of related folders and files. And if you are able to take a closer look at this slide, this is actually the XProc script. I'm sorry, I probably changed that slide too fast. Here, look at this, and then I changed the slide. Sorry about that. Taking advantage of Oxygen's project view, I developed a modular system for generating ETD metadata. The functions module contains various string manipulation functions that can do things as simple as removing a period from the end of a string to multifunction processes that convert special characters to UTF-8. Functions is included in both bpress to mods and caps XSL. The title mods function, module, parses subtitles following a colon or a question mark into mods subtitle and parses non-filing words such as articles into mods non-sort. Names mods formats bpress first and middle names into given, then creates a mods name element. It also accounts for known capitalization issues with surnames beginning with a prefix such as Day or Vaughn. Names mods also accesses the table of authorized author names and their corresponding authority value URIs. Staff from the cataloging department's authorities unit contributes substantially to the creation of that table. The disciplines module is a crosswalk between bpress disciplines and Library of Congress subject headings. If the bpress metadata didn't contain a disciplines element, then a generic subject heading was assigned based on department. A huge apology to the music library for so many of their ETDs having the subject heading of just music. The caps module converts all caps titles to proper title case. That is, all words are capitalized except for articles, conjunctions, and short prepositions. It looks up data from a dictionary of those articles, conjunctions, short prepositions, as well as known acronyms and names with mixed capitalization. This transformation uses the title case function in functions XSL to initially capitalize the first letter of all words, and the rest of the program then converts articles, etc. to the form found in the table. bpress to mods is also associated with two different XML files. The transformation is run on a collection of bpress metadata, but it also looks up data in the PDF data XML. To sync the records, we use bpress submission path value, which is the base for both the metadata and PDF file names. The first step of the XProc adds a number element with a value derived from the PDF's file name. Variables are created for the bpress submission path and for the PDF data number. And this is the little bit of XPath that does the magic. The for each sets the current node as bpress submission path. Remember, that was the variable that we created before. Within that context, any PDF record with a number element equal to the current node is selected. The current node is the submission path. Then within the context of that PDF record, the output value is set to the PDF record's data element, or whichever element you need to access. Is this process complex? Yeah, it is a bit. Is it efficient? You bet. You might say this is awfully complicated and a lot of trouble just to generate some metadata. And for a semester's worth of ETDs, maybe 100 or 200 titles, manual enhancement and authority control would be just fine. But with this migration project, there are thousands of ETDs to process. The first batch was 6,600 titles. Doing this manually within the time and staffing constraints given was just not an option. And now that these processes have been refined, the turnaround for new ETDs, usually about 150 or 200 titles, with authority control of author and committee member names, is easily done within a week. The PDF data and ProQuest to mod transformations can be completed in a day. Most of the time is spent reviewing the data and researching name authorities. I guess we're doing pretty well in time, so we have a chance to introduce a couple other technologies that we used during the process. One of the challenges we had was that the bpress PDFs had bpress cover pages. The Acrobat Wizard process explained that earlier. Excuse me, let me start over, please. The Adobe Acrobat Wizard process explained earlier took care of that. But how can we create a new FSU digital cover page? So I did some research on FOXSL, which I think of as HTML for PDFs, and learned just enough about it to come up with a transformation that pulls bpress data into an FOXSL template, which then generates a new PDF cover page. I handed that proof of concept over to the migration team's developer, Brian Brown, who tweaked the display a little, and then we later collaborated in refining it to process multiple author names for faculty publications. And now I will turn the floor back over to Dominique so she can tell you about some other scripting she developed to streamline migration workflows. After that, she will share the technology she adapted for institutional repositories at the University of South Florida.
Thank you, Annie. In addition to our XSLT, XProc, and JavaScript, we also utilized Windows command line in order to move and sort the PDFs and their data. We needed to sort the PDFs into different categories that all required different processing instructions. The categories consisted of ETDs that were suppressed, embargoed, and secured. Manually sorting and moving these PDFs would have taken a long time and presented the chance for error. Keep in mind, like Annie said, we were taking care of thousands of ETDs at this point. That's a lot to manually move. We wanted to ensure that the PDFs were moved into the correct category folders in the most efficient and fast way possible, so we decided to automate this process through command line. We did this through a brief script that took PDF files from a defined source folder and copied them into a new destination folder. The script referenced a text file that listed the PDFs that we did not want to move, and as a result, the script read that list, then only moved the files that we wanted copied into that folder. After setting the directory path, which contained the ETD PDFs, I was ready to structure the xcopy command. This brief script begins with the xcopy command, followed by the source path directory and the destination folder path. The exclude command follows, and it is linked to a text file that lists the file paths of the files I wished to exclude. Here you can see the fully formatted script in which the source folder is all PDFs 0, the destination folder is bad PDF 0, and the excluded files are linked in the file list 0 text file. The result copied the PDFs into the new destination folder while excluding the unwanted files. Since the script copies the files rather than moving the files, the original files remained in the source folder while also being copied into the new folder. This provided us with a backup safety net of backup files. And now for adaptations. We will begin with bpress to Mark 21. In the past few years, students at USF have submitted their ETDs directly to ProQuest. USF was then produced with batches of XML that contained ProQuest's metadata for each student's ETD. Prior to 2015, a librarian relied on XSLT and shell scripting in order to create MARC records for these ETDs. However, this librarian began a new position at a different university, and no one else knew how to create XSLT or any other types of scripts to automate the creation of these MARC records. As a result, staff members had to manually create MARC records by hand for each ETD. You can imagine how time-consuming this process was, and in fact, it resulted in a significant backlog since only one staff member was cataloging these ETDs. In the fall of 2015, I began my position as metadata librarian at USF, and I made the ETD backlog and workflow my first priority. I decided to write some XSLT scripts to automate the creation of MARC records for these ETDs. While planning my scripts and workflow, I had a few goals in mind. My main concern was finding a way to catalog these records in a fast, cheap, and good way. I wanted an automated process that would create full-level MARC RDA records, authority control for authors, notes for degrees and committee members, and Library of Congress subject headings. I knew that I could achieve all these goals in a fast, cheap, and good manner through using XSLT. I was inspired by my work with Annie back at FSU, but I was also inspired by Sean Averkamp and Joanna Lee's work with ETDs and XSLT at the University of Iowa. Both incorporated XSLT into their workflows to automate the ETDs at their universities. After doing some research and talking to other librarians in my unit, I developed an automated workflow for the ETD cataloging. The workflow consisted of two XSLT scripts and a third script for creating NACO authority records. The first script transforms the ProQuest metadata into bpress schema, and the second script transforms the bpress metadata into full-level MARC RDA records. The records are then manually reviewed to ensure accuracy and correct any unexpected problems. After reviewing and making final corrections, the records are ingested into the catalog. The first step of this process is to combine the ProQuest metadata into one master file. This file contains each individual ETD. After the ProQuest metadata is combined, it is ready for the ProQuest to bpress script. The script transforms the ProQuest values into bpress values. The scholarly communications librarian here at USF uses the script to ingest bpress records into the USF institutional repository. And here is an example of part of the XSLT that crosswalks the ProQuest metadata into the bpress schema. The bpress author element is created through pulling the value of the ProQuest dis-authorship dis-author. And here you can see the output of the ProQuest to bpress script for the author element. The metadata is present, but it is encoded in a new schema now. Just as the ProQuest to bpress script crosswalks the metadata into a new schema, so does the bpress to MARC script. And here you can see the output of the bpress to MARC script for the author element. The metadata is present, but it is encoded in a new schema now. Now that you've seen the individual transformations, here are the scripts and their results. You can see the transformations as a whole and how the metadata was transformed without sacrificing quality. In this example of the author transformation, you can see how the name has been concatenated and restructured. Similar transformations occurred for the rest of the metadata, which ultimately resulted in a full-level MARC RDA record. And finally, we have the result, a full-level MARC RDA record entirely created through the automating XSLT scripts. And then I have the NACO list automation. After the MARC records are created, the next step is to create NACO authority records for each ETD author. I kept the same approach of fast, cheap, and good in mind when creating this additional workflow. The goal was to create another XSLT script that would automate part of the creation of NACO records based on the metadata from the MARC records. While this script does not fully automate the NACO authority record creation process, it does pull the necessary metadata from the MARC records into a spreadsheet so that the metadata or cataloging librarian can catalog these NACO records without having to read every single ETD title page for metadata about the creator. First, the script defines MARC tags as variables which are needed for the creation of NACO records. After declaring the variables, the script calls the same variables into rows and columns so that they can be transformed into an Excel sheet for easy review and reference. Finally, another XSLT script is ran on the result so that the rows and columns containing the metadata for the NACO records is output into an Excel sheet. A librarian is then able to reference this Excel sheet to fill in many of the required fields of the NACO records. In the future, I plan to further automate this process so that these values are directly input into a NACO record through automation rather than by the manual work of a librarian. And finally, here is the list of acronyms we promised, in case you were wondering what some of these meant. And of course, we have our resources.
And if you have any questions, just contact us.
And we actually have a little bit of time for questions right now. So if any of you attendees have questions, please feel free to type them in the question box, and we'll have a little bit of time for questions before our next presentation. While we're waiting for you to start typing away your burning questions, we do have a question from Twitter, which is, when you convert bpress PDFs, are you able to bring along accessibility or ADA metadata with you, such as alt tags?
No, we were only looking to get the bibliographic data.
Okay.
There is a header on the converted XML, but I'm not sure if it has ADA data in it. It might. It's a possibility. That's definitely worth looking into. It may be possible.
Okay, great. And we have another question that just came in, which is, do you ever need to go back and update the MARC records after the NACO record is complete? So for Dominique, I think.
Yep. We are just beginning that process of creating those NACO records. The first priority was to get those MARC records in there, so we would have to go back and update those. But in the future, especially once this process is automated, we would be able to already have those NACO authorities established, and those would be created in the MARC records.
Okay, great. And we have a few more questions coming in right now, so we'll see if we can get to all of them. Here's another question around assigning subject headings. How did you assign the subject headings, and were they based on keywords in the abstract, or were they student submitted?
I guess I'll take that. What we did is we took the disciplines element in the bpress, which was a controlled list of subject terms, and we crosswalked that to Library of Congress subject headings. And sometimes it was exactly the same thing, like chemistry or music, but sometimes we had to do a little bit of research in the Library of Congress subject headings to have an equivalent. If it didn't have a disciplines, then we used the department, which was very generic, but some is better than none.
Okay, we have a few questions from people about the availability of your scripts on your GitHub pages. So a couple of people are anxious to look at those. Are the scripts that you were demonstrating examples of today available on both your GitHub sites, or pieces of them in different places on those repositories?
I'll take this one first.
Okay, go ahead. That's fine.
Yes, mine will be on my GitHub account, which is on this question page right here. I meant to do that yesterday, but Tampa had a really bad storm yesterday, so I didn't have power for a while, and I wanted to update the scripts a little bit. So after today's conference, they will be at that GitHub page.
And similarly, you know, my time was spent with this presentation. So what's up there right now are just basically examples of what we went over today. I ran the scripts to see if they would work, and they did. They're example scripts. They're not, you know, finished scripts. For example, what Don was showing you about the transformation from the PDF to the XML sometimes didn't work well. Well, if that initial PDF to XML file is not formatted correctly, then the XProc step 1 doesn't work. So if the XProc 1 doesn't work, the next step 2 doesn't work, etc., etc., and so therefore there's no result at the end. And similarly, once you use that PDF data to run your main transformation with bpress to mods, then it's not going to generate a title, for example, because with the bpress to mods transformation, the title is coming from the PDF data. So if your PDF data is not correct, then you're not going to get a title in your bpress to mod. So I actually left the bad stuff in there just as an illustration of the situations that we came upon.
Hey, great. We still have a few more questions, and I think we still have a little bit of time. So there's another question. Did you consider using OCR to harvest PDF data at all?
Well, as part of the process, we run OCR on the PDF before transforming it, or excuse me, saving it as XML. The first method I tried was to convert the PDF to text, and actually converting it to XML, because of the element structure, gave us more control on manipulating the data than just text.
Okay, great. That's interesting. We have a question for Dominique. Are you creating NACO records for authors only, or also for committee members and advisors as well?
Right now, that script I talked about only does it for the ETD author. That is all we've done so far. I'd like to expand it in the future, though, but the backlog was the primary concern at this point.
Okay, and I think we've really been able to get to most of these questions. I think we have one more, and then we'll move on to our next presentation unless anybody else has any other questions they want to type in the next minute or so. So the last question that we have is, why do you have the students submit to ProQuest and not directly to you, eliminating the need for the conversion in the first place?
Well, actually, was a decision that was made by the associate dean who's no longer here. This is a question that I think our digital scholarship team asks on occasion. This is the situation that we have right now, and this is how we're dealing with it. The ProQuest metadata does provide some good information. It provides us with the embargo dates and the abstract and some other things that is not easy to get off of the PDF. And again, when in the earlier situation where we had the student providing the metadata to the graduate school, it wasn't always the most accurate.
Okay, great. Thanks very much. We've been able to answer all the questions from the audience for this presentation, and we'll also have some time for questions after the next presentation. So if you think of some other further questions, you'll still have a chance to get some of those answered today. But now we're going to move on to our second presentation from Joseph Nicholson, who's going to address finding a new metadata MO, metadata automation on a budget at a medium-sized institution.
Yes, thank you, Anna. Appreciate the introduction. And thank you, Dominique and Annie. That was a great presentation. So what I'm going to be talking about today is how those of us at a medium-sized institution with really only modest technical skills have been able to adopt some new techniques and in some cases find new uses for old techniques for creating and transforming metadata in bulk and in automating the process as much as possible. Now there are a number of other institutions out there, some of you may be in the audience, who have been able to apply some of these same techniques with greater elegance, sophistication, technical know-how, etc. And that's occasionally caused me to wonder while putting together this talk why I am presenting on the topic rather than one of you. But then I considered that it might be useful, maybe even encouraging, particularly for those of you working in similar situations, to see how those of us at a decidedly non-creme de la creme institution are coping with some considerable metadata challenges with some success, despite budgeting and staffing constraints, and to understand something about the tools that we're using to do that, most of them very low-tech tools. The theme of the pre-conference is, after all, we can do it, you can do it too. But it wouldn't hurt my feelings fatally if one of the main takeaways from this particular presentation were, we can do it, but you can do it even better, or figure out a better way. And so, at the risk of rushing in where angels fear to tread, let me continue. But actually, before I get started in earnest, I do want to tell you a little bit of something about where we'll be heading during this presentation and where I hope we'll end up. I am going to be talking right at first about my organization and describing some of the organizational changes there that have some bearing, some effect on metadata workflows. I'll describe some of the major new digitization initiatives in special collections and then focus in some detail on the techniques, both extremely low-tech and more high-tech, that we've used to cope with the metadata demands of those projects. And finally, I shall wrap up by saying something about how we've been able to transfer those techniques to other projects that we're working on. And then, mercifully, I shall stop talking. So to begin with, a little bit of information about us, where we're calling from, where I'm calling from at UNC Charlotte. Well, we are a medium-sized institution. We don't have the layers of staffing and specialized roles that a lot of places have, although we certainly have more people involved in metadata creation than others. A few years ago, just before I came on board, there was a tumultuous reorganization of technical services that resulted in the loss of some major cataloging talent and the transfer of other staff to new roles and new departments, mainly special collections, which is now creating most of the original metadata for the entire library and in fact doing all original cataloging for the library. Now there are several folks involved in metadata creation in our department. There's only one full-time staff person dedicated to doing that, and that would be me. Interestingly, we have a couple of staff members with the job title metadata cataloger, but they do archival processing work that is unrelated to digitization. One other point is that we recently became members of the NACO program, the Name Authority Cooperative Program, whereby libraries submit authority records for personal names and corporate bodies and geographical places to the Name Authority file, but the trained staff to do that work and the time is extremely limited. And finally, I'd say that though we have some brilliantly talented people working in IT in our library, the technical skills of those of us working on metadata, I would say, are modest at best. I'm a good example of that. I'm a cataloger by training, by temperament, for better or worse, mostly for worse. You know, I've worked with the major cataloging tools, a lot of work with MarcEdit, some experience with EAD files, a bit of experience with XSLT, but really my skills are nothing to shake a stick at. But these rather modest skill sets and limited staffing levels have been put to the test, challenged by some major changes that are going on in special collections. And some of those are, well, like a lot of other institutions, we're moving away from a boutique digitization model to a mass digitization model. We're digitizing entire collections or large swaths of them. Although we do have some content in our old Content DM repository, we're now putting new collections in a new repository built on the open source Islandora platform. And that's required us to make some major changes in the way that we create and manage our metadata. Namely, we're now creating MODS records, the metadata object description schema, for the new repository. That's kind of the mother schema of this new repository, rather than the Dublin core records of the past. And we do have several ambitious departmental digitization initiatives ongoing. But though we've acquired some new equipment for that work, for the digitization side of things, we haven't added any new staff to handle the metadata workflow, which has greatly increased. So that sort of leads to an Icarus-like situation in which one is soaring aloft ambitiously on wings of all too human engineering. You never know when the sudden plunge is going to happen. It hasn't happened yet, but of course failure can take different shapes. It can be a slow, gradual, gentle descent, but the meeting of the cold, icy water beneath is just as shocking, whether you drop like a stone or sort of waft gently down into it. But I'm getting a bit away from the matter at hand. What I'd like to do is tell you a particular collection that we're working on that kind of represents the challenges in terms of metadata creation that we're dealing with for this new repository in Islandora. It's the Motorsports Photographs collection. It's a large collection of more than 100,000 images that were donated to us a couple of years ago by a noted motorsports photojournalist. They're mainly images of NASCAR events, although there are other events in there like rock concert events. And the images are of cars speeding around tracks and crashing and people cheering on the sidelines and rambunctious sort of ribald stuff going on in the grandstands and beauty queens and striptease artists cavorting about. It's kind of a wild bunch of stuff. And this collection was sort of presented to us suddenly one day, and we were told, figure out how to deal with this, and we more or less had to. Now, one of the madcap ideas we have about this project was of creating item-level metadata for every single image in the collection, and also of creating NACO-compliant terms, controlled vocabulary terms for every single person that we identify in the images, every single racing venue, every single track name, every single race. Now, donor metadata is also an essential component of this project. We're relying on the donor to help us identify people in the images. And so one crucial need, and we knew this early on, was finding a way to fold his metadata into our metadata mix in a way that was kind of seamless. But by far the greatest challenge of this project was, and we knew this from the very beginning, getting a huge volume of metadata out of Excel spreadsheets, which we were going to use as sort of the staging ground for this project, and into MOD's XML records in a way that was swift, that was painless, that did not require a lot of sophisticated technological skills, no scripting, no coding, and that even a student assistant could do. The end result of the process would have to be, we knew, individual MODS records for every image. Now clearly for a project of these gargantuan dimensions, a single record approach method of creating records, creating them in some kind of form was not going to be an option. We needed a batch creation process. So I'm going to tell you now about some of the, I'm going to get a little further on to describing some of the more sophisticated ways we've dealt with these challenges. But first of all, I'm going to go through and mention a few low-tech ways that have been just as important in speeding things up on this project. So we decided early on that we were not going to give individual distinctive titles to any of the images in this collection. This large photographs collection is divided into smaller sub-collections, each of which contains somewhere between 80 and 120 images each. And these sub-collections represent specific NASCAR or rock concert events, like the 1975 Daytona 500 events. So what we do for all of the images in these sub-collections is simply give them the same base name, 1975 Daytona 500 events, to which we then append image 1, image 2, image 3, image 4. And that allows us to assign title metadata extremely quickly. Another thing we've done in this repository for all collections, not just the motorsports collection, is to switch from LCSH terms to FAST, faceted application of subject technologies. It's something that I have a lot of qualms about, being something of a dyed-in-the-world cataloger, even though I'm the one that made the call. It's simply that our students, we rely very heavily on student labor, most of them wonderful, but they simply don't have the time to learn to apply complex LCSH strings in multiple thousands of records with the required accuracy and acumen. FAST is a simple, reliable vocabulary that they can apply with much greater ease. QTools is an extension program of Excel, has something that has also helped us out with the metadata creation and with the donor metadata creation. It's a tool that will allow you to, among other things, load images into a spreadsheet. And we kind of use those images as reference points when we're creating metadata in spreadsheets, particularly for things like subject terms and name terms. We were also using the images for collecting metadata from the donor early in the project. He had some elementary proficiency in Excel, so we would send the spreadsheets to him, leave a column for his name ID information. He would fill it out and return it to us. We've since switched to a new, more sophisticated method for collecting ID, people ID data using a web form in our repository, which interestingly has slowed our work down quite a bit. So we realized that there are about 150 people that reappear over and over in these images, and perhaps about 50 to 60 fast headings that we use repeatedly, a slightly different group for the motorsport stuff. And we found that the easiest way to assign these in this project is to gather those established terms for those names and subjects together in columns in tab 2 of our spreadsheets, and then click them very quickly into place in tab 1 using drop-down menus and data. Now, using data validation to insert values in cells and spreadsheets is pretty easy if you're just going to insert one value at a time, but if you want to insert multiple values, you're going to need some kind of coding, and I found some of that readily on the web and have kind of tweaked it for our purposes. But it helps us apply these subject headings and terms very quickly and without errors. You'll notice that for these terms up in the upper left-hand corner that they are connected with uniform resource identifiers for fast terms. In version 3.4 of mods, they introduced an attribute value for uniform resource identifiers of controlled vocabulary terms, and a sort of a nod to linked data. And we found that the best way to get those in there is to hook them together to the terms themselves and then break those strings apart later in OpenRefine. But OpenRefine has really been the project's workhorse. It's what we rely on most heavily to get the work done. I think most of you are probably quite familiar with OpenRefine and may use it even daily, and perhaps this would be a good time to do that brief poll, which is just sort of trying to collect some information about how frequently and widely it's used. Perhaps I'm going to be the one that runs it. Okay, Okay. All right, interesting. Some people have used it never, some occasionally, about 10% are using it daily or weekly. Perhaps we could hide the poll now so that we can continue. Thanks, everyone. So for those of you who don't know much about OpenRefine, it's an open source program that you can download from the web to your local machine for free. And you can feed data of various formats into it. Most of us in libraries, I think, tend to feed tab-delimited spreadsheet data into it. And you can use OpenRefine to clean that data, to track down rogue elements in the data, badly formatted characters, misspellings, inconsistencies, and correct that data in very short order. You can also use it to match keywords in your metadata with data in an external data set, like a linked open data. Perform a reconciliation routine. Now, I think that those particular functionalities of OpenRefine are pretty widely understood or known about, even if you don't use them frequently. I think what's a little less known, but becoming rapidly more known, is OpenRefine's ability to transform metadata in spreadsheets into other schema, like mods XML, very simply and rapidly. Now, this is not at all a technique that I pioneered myself. I think a lot of us in the Islandora community are using it. What I'm going to be demonstrating it here is how I am applying it to this extremely unwieldy project that requires us to push huge volumes of data in and out of OpenRefine to get mods records on a daily basis. So what does this technique require? Well, it requires a pretty solid knowledge of the metadata schema that you're transforming the spreadsheet metadata into. It also requires the ability to create a spreadsheet with column titles that correspond to specific elements and attributes in that schema. It requires you to create a template record in something like Notepad or WordPad in that schema. And finally, although it's not absolutely necessary, your life will be much easier if you can do some post-processing of the data that comes out of this transformation with XSLT. So the first step in this process for us is creating a spreadsheet for each one of these sub-collections. We have a template spreadsheet that contains all of the column titles that we use in the project that is pasted very quickly into place. We have control values that we transfer to the spreadsheet from an authority control spreadsheet that has multiple tabs, contains all of our authorized controlled value terms. Those are dragged down the spreadsheets very quickly. We apply subject data and name data in the way that I was just suggesting. And presumably, you will have become well enough acquainted with the schema that you're working with at this point to be able to use the correct formatting standards for dates, controlled vocabularies, and content standards that are appropriate for the various elements and attributes in the schema. At this point, the spreadsheet is loaded into OpenRefine. We actually save our spreadsheets as text files. It allows us to get rid of the images much more swiftly. You don't want to load images and metadata into OpenRefine, or it will cause it to sort of have an aneurysm. So once the spreadsheet is in OpenRefine, the data will be presented to you in rows. Each row represents a separate record that you're creating in a collection, and at this point you could use all of OpenRefine's heralded data cleaning powers, the clustering, the faceting, the use of Google Refine expression language to track down inconsistencies and misspellings and generally burnish your metadata to a high shine before you begin the actual transformation. I'm not going to go into describing those techniques here because I think they're amply documented elsewhere on the web. I have listed a couple of useful references on the references slide at the end of this presentation. So at some point prior to this step, you will have created a template record in something like Notepad or WordPad in the schema that you're going to be transforming your metadata into. It's a kind of representative record that includes all of the attributes and elements that are used in your spreadsheet data. Now, not all of those records in your spreadsheet will necessarily make use of every single one of these attributes and elements, but you want to make sure that all of the ones that are there, because if there are columns in your spreadsheet that don't have a corresponding element or attribute in the template record, those columns of data will not come over during the transformation. And what goes in the template elements and attributes are not actually literal metadata values from your spreadsheet, but rather enclosed in this JSON syntax of curly brackets and square brackets and quotation marks, the title of the column in your spreadsheet that contains the data that is destined for that particular element or attribute. That column title must be spelled and formatted in exactly the same way that it does in your spreadsheet. If there's the slightest discrepancy, an uncapitalized character, a dash left out, then the metadata in those columns will not transfer during the transformation process. Now what's going to happen during this transformation process is that the metadata in each row of your spreadsheet is going to be inserted inside the elements and attributes containing the corresponding column title in the template record. And an individual mods record is created for each row of data in the spreadsheet that you imported. And all of those individual mods records are going to be concatenated together within a large mods file that is wrapped inside a mods collection element and closing tag. And indeed, it is difficult to use this procedure with a schema that doesn't have some sort of collection level wrapper that enables the carrying of multiple records. Now, there are some pieces of data that may repeat from record to record, from row to row in your spreadsheet. It could be that for the metadata spreadsheet that you're creating and transforming, the publisher data is the same, maybe the place of publication is the same. It could be that the creator data is the same for every single one of the records you're creating. If that's the case, then you could actually place those values in the template record itself, as you see here. That will spare you the trouble of recording those values in the spreadsheet. You can apply them once here, and they will be applied to however many records that you create through this process, whether it's 200 or 2,000. Now, in most of the cells in your spreadsheet, you're only going to have one value a piece, but you will probably remember that we were using drop-down menus to insert several terms for subjects and name values in certain columns. If we leave those cells as they are with multiple values, what's going to happen is that multiple values are going to get crammed into single subject authority tags and attributes in the resulting mods record. We don't want that to happen, so what we need to do is split those values apart in those columns so that there's only one value per cell in those columns. And that's a pretty easy thing to do in OpenRefine. It's much easier to split cells in OpenRefine than it is in Excel. Up in the upper left-hand corner here, you can see a couple of cells in OpenRefine that have multiple values, fast terms with their URI separated by semicolons and backslashes. We do an initial split on the semicolon, and that breaks that column apart into columns with fast heading URI pairs, and then we do a second split on the backslash, and that breaks those pairs apart into individual columns that contain single values of fast headings or URIs. And once we've got that data sorted out into separate columns, then we can simply do a quick renaming of the columns in order to match what we have in our template, and that will ensure that data from the spreadsheet is targeted to the right place. We use several template records in the work that we do for this new repository for different projects. These are just quick examples of some others that we use. On the left is a snippet of one for mass digitization of manuscript for a folder and a complex hierarchy, collection hierarchy, and on the right-hand side you can see a bit of a template record that we use for oral histories. These can be edited on the fly. They're not fixed in stone. You can adjust them at the moment of transformation. They're very useful. And the transformation is quite easy to do. Transformation is always such a grandiose, sort of mystical word. You imagine that something more fine and special and even mystical is going to come out of the process rather than just more metadata. There's a kind of post-transformation tristesse that sets in after the process, but maybe it won't for you. Maybe you'll find it exciting. But whatever the case is, it's an extremely easy process. You go to the upper right-hand corner of the OpenRefine main screen, you click Export. Then you choose Templating from the drop-down menu. This templating export pops up. On the right-hand pane of that box, you'll see all of your metadata gathered together, waiting for transformation. It's in the left-hand boxes, the left-hand panes, that you paste various parts of your template record. In the prefix box goes your XML declaration and the mods collection root element. The mods collection suffix goes in the bottommost box, titled suffix. The row separator is left blank. The row template is where the body of your template record is pasted. When that's done, and when things look ship-shape, you simply go down to the bottom right-hand corner and click Export. A record is exported in your new schema in Notepad. You save that record, you change the file extension to XML, and you've completed the transformation. You've created, out of that spreadsheet metadata, a new file of records in mods XML without too much trouble. Now, there are a couple of problems that may need to be addressed with this file before you can make use of it in a repository setting, say. Some of those problems are cosmetic, others are more serious. I'll get to the more serious ones in just a moment. But you may find, for instance, that you have null values, clusters of tags without actual metadata values in the resulting file that you've created, such as are indicated by the bracket over on the left. There is a little check mark that you can uncheck at the very beginning of the Open Refine process when you're loading a spreadsheet in there. You can uncheck Store Blank Cells as nulls, and that may prevent empty cells from being turned into these kind of values. But we find that the splitting procedure that we do with the subject terms inevitably results in some of these empty values. And it happens because our spreadsheet template, which you see over here on the right, makes room for up to 8 subject headings and name terms, but most of the records we create only have 3 or 4, and so for all of those unused clusters of subject tags, what results in the mods file is an empty set of elements. Another problem might be that you'll find that the element contents of every element in the mods file is surrounded by quotation marks. That's something that could possibly be removed through an XSLT, or you could load it into an XML editor like Oxygen and do a find and replace that targets individual element contents, and that would prevent you from removing quotation marks from attribute values. The other larger problem, though, with this file is that you've got this large file of perhaps 200, 400 records, a single file, and to make use of those records, you need to break that file apart and get individual records for the images out of it. And ideally, each of those files will have as its file name the same identifier as the images. There are a number of non-XSLT ways you could go about doing that. Most of them are pretty painful and might make you cry. We found that this extremely simple XSLT does the work. It takes care of the cosmetics problems and also the splitting problems. Now I call it a baby XSLT because it's doing such basic stuff, though unlike a real baby, it only produces clean, odorless metadata records that go in a folder that does not leak. But sometimes I think that the value is just about as equal to that other product. Be that as it may, there's a lot more complicated and sophisticated processing of your data that you could do at this point, but this seems to be doing everything that is adequate for this particular project. What's happening in the spreadsheet is that the result document element is creating multiple new files from the original mods collection file. The href attribute of that element is indicating that we want each of those new records to have the identifier as their file name, and the identifier is an element of metadata that is included in each of the metadata records that we've created. The copy of element further down is simply sandwiching the contents of each of those individual mods records that are in that large file in between a mods opening and closing element that are more appropriate for a single mods records. And the select attribute is targeting those empty nodes and stripping them, scraping them out of the file. I do have some links on the final screen of the presentation to the few simple XSLTs I use. I'm not sure why you'd want to go there because there's so many dazzling things to see in GitHub, like the things that Dominique and Annie were showing us. It would be like going into a swank, fancy grocery store and choosing of all the kind of aromatic, fancy coffees, that little jar of Postum that's kind of sitting there neglected on the shelf. And Postum doesn't even have caffeine, but maybe someone will find it useful, can build on it. So the result of applying that XSLT is a folder full of newly created individual records for everything that was in that large collection level record. Those metadata records are paired with the image files in a directory in Seagate. The only difference in their file names is the file extension at the end, TIFF and XML, and from there they proceed to happily wedded bliss in our repository. Now once you've mastered those basic techniques, then you can use them for other purposes. For instance, migration of data. We know that we need at some point in the near future to get our metadata collections that are in Content DM out of there and into Islandora. It's not something I'm recommending that you do, but sometimes this is a task that is kind of foisted on you. You could hire a third party to do that work for a cost, but it may be that you could use OpenRefine to do much of the transition work, the migration work. Content DM, much like other repositories, will allow you to export your Dublin Core metadata for your collections in a tab-delimited format. You can take that tab-delimited metadata, a spreadsheet, get it into OpenRefine, map those columns of Dublin Core metadata to mods elements. You probably need to do a lot of heavy-duty cleaning at this point, much more so than we did with the motorsports metadata. And then you could create a template that maps that data to mods, do the transformation, and get mods records for your repository out of this process. We've done some successful trial runs with this as a kind of preparation for the coming migration. I know that there are other institutions out there that are a lot further along, like the University of Connecticut. They've proved that it really can be done. Now, during most of this presentation, we've been working with data, tab-delimited metadata, because if you can get metadata into that format, you can do a lot of things with it in OpenRefine. Now, we know that there's a lot of different ways that you can get metadata into a spreadsheet. You can type it in painfully row by row. You can copy it in, or you could do something like create a Google form, which is something a lot of us in libraries use to create surveys and things like that. So you could use a Google form to create metadata. It might come in handy for working with staff or students who are unfamiliar with a schema, or uncomfortable with hand coding a file. So let me talk about one project that I've used this technique on. I mentioned earlier in the presentation that we're a NACO institution, but that the staff for creating these records and the time to do it is extremely small. So I'm constantly on the lookout for sources of metadata that I can grab and incorporate, use as raw materials in these NACO records. So we do have some oral history staff, some of them graduate students, who are compiling the elements for mods records for Islandora. We ultimately turn those into MARC records in our catalog. And they're also putting together NACO-compliant name terms for the people and organizations that are mentioned in the interviews. So my ultimate ambition is to get one or two of them trained in creating authority records and trained in MARC. At this point, they have no knowledge of MARC whatsoever. So as a stopgap measure, I was thinking if I could grab some of that data, I could at least get some MARC records, some authority records out of their work. So what I did was I created this rather simple Google form. I won't go into the ins and outs of creating a Google form because it's so simple. Even I can do it without crying. So I collected a few elements of basic authority data, like birth date and death date, name forms, professional terms, occupation terms. The only thing I'll say about creating a form is that one nice thing about Google Forms is that you can include instructions about how to format the data for the people who are filling it out, and you can, of course, tailor your responses in certain ways, have a short text blank for very short answers, a longer text box for longer answers, maybe a drop-down menu in which you could insert controlled vocabulary terms. So they fill out that data. It goes into a spreadsheet. I have another template for transforming it in OpenRefine to MARC XML authority data. So I go through the same transformation method I demonstrated earlier with this data. It's transformed into MARC XML authority records. I run this very brief, another baby, XSLT, mainly just to clean some of the empty elements out there. I do want to leave all of the empty sets of quotation marks in the file because those signify blank indicators of MARC fields. And then I convert that file very quickly to MARC using MARC edit. And from then, the file is imported into OCLC connection, and I don't have to break up the file or split those records. because you can load concatenated MARC records into OCLC connection just fine. And here I can edit the data that has been contributed. I just want to reassure you, those of you who are tempted to turn me into the PCC police, that of course these are carefully vetted and checked before being submitted into the file. It's really just a way of getting data from another source into authority records. And so in closing, really, I would say that the takeaways of this presentation are, I hope, that simple and mostly free metadata tools will perform a lot of complex tasks and do a lot of heavy lifting for you, and that you don't have to have scintillating technical skills to master them or use them, and that once you've mastered those tools, you can apply them to a number of different projects and uses, and that you don't have to feel like you're a member of the metadata cognoscenti to do this. I often feel that I'm going about my work, and probably this this presentation has amply demonstrated it in an incredibly shambolic and crude, maybe even barbaric way. But I seem to be getting the work that I need to get done. So I would urge you to blunder forwards, bang away with the tools that you have at your disposal, and do what you need to do. Rather like this macaque, which is using a simple hand tool to crush something, I fear that it is not an inanimate object. It may be some sort of shellfish or something. An example of the Thanatos drive in the animal kingdom. But what I would urge you to do is to honor the life force by building connections with your metadata with some of the tools that I've showed you during this presentation. Thank you.
Thank you so much, Joseph, for that great presentation. There are multiple people on Twitter commenting on how delightful it was. So I just wanted to say, if you have any quick questions for this presentation or the previous one, go ahead and take a couple minutes to type those in, and we'll see if we can get to just a few of them. Oh, so one question that's come in is that for Joseph, you include the linked data URI for subject terms in your metadata. Does that mean that authorized headings are automatically updated in your metadata when the heading string is changed in the national authority file?
My sense is that in our current repository, no, that's not happening. That is my sense of things as they stand. I think that's clearly what we would like to see happen.
Okay, and then there are a couple other questions that have just come in about Google Forms. One is that, do your staff or students writing metadata work mostly in Excel, or do you build Google Forms for most projects?
They work pretty heavily in both. The Excel form was a kind of experiment, a kind of one-off thing to see how well that would work, because it seemed better tailored to that particular type of data.
Okay, great. We have a request for you to share your Google form for authority record data. And then there's another question asking what your favorite resources are for OpenRefine templating.
My resources, well, I think there's a lot of stuff out on the web. It was the first resource, the first time I saw the procedure mentioned was a couple of years ago in a blog post by, I think it was Sarah Lane at the University of Toronto at Scarborough. I know that the Google Refine book that's listed on the final slide of this presentation does not cover the templating procedure. There are, I've noticed, a couple of blog posts and informal sorts of tutorials on the procedure. But
okay.
Yeah,
we're getting a lot of questions, and I think maybe we'll take just one more, and then the other questions, if people still want to type them in, I think that we'll have to see about answering those offline. But thank you everybody for submitting questions. So one more question that I'll ask right now. is a question about what tool you use with the drop-down menus to add controlled terms. Is this web-based?
Well, it's a code that I insert into the main tab of Excel. It's very simple. I'd be happy to share it. It's not complicated. All it's doing is allowing you to stick multiple terms in cells and sticking semicolons between them.
Okay, great. So maybe
And
that's something
yeah.
we can follow up with on later.
Sure. Mm-hmm.
Okay. Oh, and one other quick question. Do you have a GitHub account?
I do, and I think that, let's see, do you see the image credits? No, we're on the image credits. Now we're on resources. I think if the fourth item down the page where you see Simple Baby, XSLTs from this presentation and GitHub, you will find some of them there.
Okay, great.
The post XSLTs.
Thank you so much, and I have a few wrap-up slides to do, which I will present now. So I just want to thank Annie, Dominique, and Joseph for providing us with valuable information on metadata migration techniques and tools and scripts used for data conversion. I know that I learned a lot today, and I hope that everybody here also did too. I want to thank all of the co-sponsors who helped us promote this virtual pre-conference today. If you haven't already signed up for our second session tomorrow, there's still time to do that, and the details on the registration for tomorrow's ALCTS pre-conference can be found on the ALCTS virtual pre-conference webpage shown at the bottom of the slide. So please join us tomorrow to learn about editing legacy metadata for ETDs and large-scale metadata remediation. Also, just if you're planning on going to Orlando, there's one in-person ALCTS pre-conference being offered at the ALA annual conference, and details and registration for that ALCTS pre-conference can be found on the ALCTS webpage shown at the bottom of the slide. We want to thank you very much for attending today. We hope that you found today's presentations useful. And just a quick reminder that you'll soon receive a short online evaluation form. Please take a few minutes to respond to the questions and return the form to us. Your comments are very valuable, and they help the ALCTS Program Planning Committee plan new virtual pre-conferences and webinars. I'd like to thank Ai-Ping Chen Gaffey of the Continuing Education Committee for providing essential technical support for today's webinar. Support that she and her colleagues on the Technical Support Subcommittee make it possible for us to present these webinars smoothly. I'd also like to thank Megan Doherty from the ALCTS office and members of the ALCTS Program Committee for their help today. Thank you very much for joining us this afternoon, and we hope you participate in other ALCTS webinars and continuing education offerings again in the future.